Hi, Professor Bob Young back at you here. In this instructional video, we're going to look at quadratic functions, some graphing techniques we've really talked about in previous videos and lessons, and our friend completing the square is back. The blankety blanks. I told you you would need it again for those of you that didn't believe me. So we're going to start out here defining what's called a polynomial function. A polynomial function of degree n, where n is a non-negative integer, is a function defined by an expression of this form: f of x equals a sub n x to the n power plus a sub n minus 1 x to the n minus 1 power plus dot, 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 could be a whole bunch of stuff in there, or maybe nothing else, plus a sub 1 x to the first power plus a sub 0. Now, I know what a lot of you are saying there. That's kind of scary, Young. Now, really, the a numbers in order there are coefficients of the polynomial in descending order of powers, x to the n minus 1, and so forth. So we're going to look at such a creature here next. So let's take a polynomial function, f of x equals 2x cubed minus 1/2 x plus 5. Notice that the n is 3, and the polynomial has the form below here. So that's what we were looking at before. So let's just line up our ducks in a row here. And you know me, I like to get some pretty colors and work with. So we'll just go ahead right under here, and we will put this polynomial above in descending order. Now notice there is no x squared term here. So those a numbers, again, are simply the coefficients in front of the variables of different degrees, starting with x to the third and ending with the 5, which really has no x power on it. So, you know, don't get intimidated by some terminology in math. I mean, you just have to kind of get some examples and look at things, and it won't be very scary, hopefully. Now this we've seen before, this quadratic form from previous sections, the old ax squared plus bx plus c, when you have this in functional form, it is called a quadratic function, just like we had the quadratic equations of previous lessons, and we've done lots of things solving quadratic equations, the quadratic formula, all that kind of good stuff. Now, when we get to graphing these creatures, these are really graphs of parabolas. So when you see the word quadratic function, think of our friends, the parabolas. And here's one we have seen before in our graphs of common functions, the old y equals x squared here. So we're going to look at this graph, and notice we've got the domain here, the x values, and this is true for any functional parabola. Notice on x that this thing is going to keep going and opening both directions wider and wider and wider, and the domain of any functional parabola will be all real numbers. So this is something we want to look at. Now, the y values here, and I'll try to do a green similar to the green in the graphic here. The y values start here at 0 and go up this direction. So the range, or y values, is 0 to infinity. And do you see why they put the bracket on the 0? It's part of the graph. It is included. So remember this basic graph, and oh, will it help you with the others? Also, now we're going to find out that these functional parabolas are always symmetric with respect to a line. And this line, some books call it the axis of the parabola. I like the axis of symmetry, and that line cuts the parabola in half going through that point, which is called the vertex. And the vertex is the main point you always want to get when graphing a parabola, and there's lots of other applications for our friend the vertex as well. Now, in your supplemental handouts, if you're a lecturer or hybrid student, you were given this the first day of class, or online students can get it in Angel here. We've got a whole bunch of interesting features of quadratic functions, and this will help you as you proceed in the chapter. So notice we've got an alternative equation here in the middle, and this is the one we're going to look at first in this video. We've already kind of discussed this one in terms of polynomials, our y equals ax squared plus bx plus c, and we're going to talk about in the next videos lots of ways to play with that. But we're going to look at what's called standard form for these quadratic functions first. And this is y equals a times x minus h squared plus k. And notice this hk number here. The hk numbers are really the vertex of the parabola. And I'm going to go to a different color here, red. This number in front of the quadratic function, the a number, tells us which way the parabola opens. Now, if a is positive, if a is greater than 0, your book will say it opens upward. But Young's got a better word for this. He says when a is positive, the parabola smiles. When that a number in front is negative, the parabola opens downward. That's what the book says. But Young says it's having a bad day. It frowns. And notice even up top here on the handout, even in the other form, there is an a number there too. So this a number, I don't care if you're talking the ax squared plus bx plus c or the standard form we're going to get into, it will tell you which way the parabola goes, and that's another huge thing here. All right, so we're going to graph our first parabola. Woohoo, woohoo. All right, so notice this one says f of x equals x plus 2 squared minus 1. Now, let me just refresh y'all's memory. It hasn't been that long in the video already, but we know that the basic function y equals x squared, or f of x equals x squared, starts at the origin and looks like this. Geez, I almost missed the origin there with my writing tablet. There we go. All right, now if you remember the old translation sections here, we're going to make some ordered pairs up. So let me just go ahead, and I'm not going to make a whole bunch of ordered pairs, and I'm going to show you the coolness of graphing parabolas here. We don't need a lot of ordered pairs once we get that vertex. That is all important. Okay, now on this one, if y'all remember from previous lessons, that minus 1 tells me something. It tells me that that parabola is going to shift vertically down 1. And y'all remember about the plus 2 in there, which way that goes? That's a horizontal shift. I hope you remember this. You did decent on the last test you did. It shifts 2 directions left, the direction you don't expect. So, the things we've got to remember in here. So this would tell me if I went 2 units left from the origin and down 1, there would be my vertex point, which would be what? Oh, I didn't go 2 left, sorry. Let me see if I can, well, I'll just go ahead here and take a different color because I missed the point here, my writing tablet here. It seems to be giving me a little trouble today. I'm going 2 left and down 1. I'll do it in green this time. There we go. I got it that time. You don't know how hard it is to line these videos up sometimes, those of you outside of video land. Now notice if we put negative 2 in for x, this becomes negative 2 plus 2, so we get 0 in that big old parentheses there, minus 1. So when x is negative 2, y would be negative 1, and there I'm going to put v for vertex. Also, does this parabola smile or frown, Young? Well, Young, I don't see the a number. There's no a number in front of the parentheses here. Yes, there is, ladies and gentlemen. A is 1, and that speaks volumes because I know the parabola is going to what? Smile, open upward. So I'm going to put this axis of symmetry right here. So right away, I know the axis is going through x at negative 2. So the axis of symmetry, x equals negative 2. The vertex is negative 2, negative 1. Y'all should be able to tell me the domain of this thing before I even graph it because it's true for all functional parabolas. And why is it a function? It's going to pass the vertical line test, and each different x will correspond to exactly one y. All right, now I don't know if y'all ever go to Publix. I like going to Publix because they always have those buy one, get one free sales. I know that's crazy. Y'all are thinking, Young, what are you talking about, buy one, get one free? But when you know the vertex of a parabola and the axis, I'm going to go ahead and just take a few points close to that axis of symmetry, and I'm going to try to pick easy ones here. I'm going to put negative 1 in for x. So we can do some evaluating functions here. So f of -1, looking at that function up top, if I put -1 in wherever I see an x, let's see if y'all agree with me, I'm going to get -1 plus 2 in the parentheses is +1 squared minus 1. That's going to give me 0. So when x is -1, y is 0. So watch me, I'm going to plot this in green now, above that point I already messed up there. All right, so there it is. Now here's what I mean by buy one, get one free. If that point -1, 0 is there, that axis of symmetry tells me, well, -3, 0 would also reflect across that axis of symmetry. And I bet you if you put in -3 for x, y will come out to be 0. Anyone want to bet? Lunch, $100, quarter? All right, well, get back to me on that. Then I'm going to put, now you can also see that parabola opening, can't you? You can start seeing the picture of the graph. And then I'm going to put in 0 for x and get one more point here. And I think we'll have enough points, so we don't need a ton to graph the parabola. So f of 0, let me come over here and do this on the bottom somewhere. F of 0 is going to be 0 plus 2, quantity square, minus 1. So that would be 4 minus 1. We'd have 0 plus 2 squared would be 4 minus 1. So I get 3. So here we go. You ready for this? Buy one, get one free. So I'm going to plot the point 0, 3 up top here. Now, do y'all see how far that is away from the axis? It's 2 units. So I'm guaranteed to have a symmetric point there. And that would be at -4, -3. I bet you that'll check too if you want to try it. And let's go ahead and connect the dots. And here is the easiest way to graph a parabola in this form. And again, it's hard on this writing tablet to hit all those points and stuff, so forgive me, but I think y'all get a good idea. All right, so the domain we can talk about, and finish this one up, is -infinity to infinity. And the range would start at, on y, and I'll look down here, -1, heading toward infinity and beyond. Buzz Lightyear. All right. I would usually stop and say in class, questions, so that y'all can look at this a million times over. Let's try another one. Graph this function, and again, we have, guess what? Standard form here. So I'm going to go ahead, and we want to go ahead and see if we can speed this up, because I want to go ahead and make sure we got, don't want to make these videos too long if I can help it. The vertex on this one, do y'all see? With that +4, it would shift the graph of the basic parabola 4 units up. And then with the -1 there, which way? 1 right. So if we go from 0, 0, if we shift 1 right up 4, our vertex, or V, I'm going to call it, is going to be the ordered pair 1, 4. Let's write that right above vertex up here. The axis, well, it's going to be, it's always that x value part there, x equals 1. Now, which way does this parabola go? Does it smile or does it frown? Well, that -2 in front, the A number, tells me, and if you weren't paying attention, you can stop the video and go back. It's going to frown. So I'm expecting this thing to go this direction. So this is kind of nice to know. If you screw up any points, and you get a point above that vertex somewhere, like if you get 210 or something, you screwed up, because the way it's sitting, it's got to go downward or frown. All right, now what x value do you all want to pick first, looking at where the vertex is? Now, me being lazy like I am, I'm picking 0. And then I can come over here somewhere up top. I think I'll go up top here so I don't run into my graph. F of 0 is going to be -2 times 0 minus 1 square plus 4. All right, now -1 square, 0 minus 1, this would be a +1 in here, times -2 would be -2, plus 4 would give me a +2 here. And hopefully this point will make sense. So if I go 0, 2 and plot it, notice it is indeed heading the frowning direction. Yes, it's buy one, get one free time. So since I got that point, here is it's buy one, get one free. And you can already see that rascal heading downward. All right, let's get one more point here. And it doesn't matter what you put in. I'm going to put a 0.3 in here for x, and then we'll evaluate this function when f of 3 happens. So this is where evaluating functions came in handy before, and we'll continue to do so. So here, 3 minus 1 is 2 squared, would give us 4. So we'd get 2, negative 2 times 4 would be negative 8, plus 4 would be 3. At 3, we would be at negative 4 on y. So let's see how that looks. And to me, it's looking pretty good. Now, also, if you get that point, notice how far it is away from the axis. How far do y'all see? 2. I'm going to go over 2 this direction, and I hope my writing tablet will allow me. Good. All right, and if I can hit the dots now, you can see this parabola. All right, so let me, and make sure your parabolas, when you get to the vertex, have a rounded curve. You don't want to try to make it look like a V or anything. Sometimes I get students who make a parabola look like an absolute value graph, and that's not bad. So if I can do it here on this shaky writing tablet, y'all can do it at home on a nice piece of graph paper with a pencil. Okie dokie. And again, the domain is going to be on this one, negative infinity to infinity. See, even if it opens downward on x, it's going to keep getting wider and wider and wider both directions. And the range on this one would be starting the y value start up here. So really that vertex, if you look at it here, the vertex, and I'll put V over here again, helps you with the range, because you know it starts at y at 4 and heads toward negative infinity. So in interval notation, negative infinity 4, smallest to largest order. And also notice that negative 2 in front did not only tell me the parabola was going to frown, but if you remember previous lessons with translations and reflections and stretching and stuff, this negative 2 here told me that the parabola was going to get skinnier. And it kind of did than our normal regular one. And getting into that, I'm going to throw some other stuff at you here. Notice here, and the graphs are already done so we can save time on the video, if you put a negative fraction in front of the y equals x squared, remember the green here is our normal y equals x squared. What's the 1/2 do to it? If we started plugging in points and stuff, it gets fatter. Now with the negative on it, it flips it about the x-axis. See, so there's a lot of good things that translations and reflections and stretching and stuff will help you with when you graph this. And of course they give the domain and range on this one as well. Pretty cool stuff, huh? Here's another one. We've got the negative 1/2, and they threw some numbers in here. So notice here, the vertex, we just shifted over 4 units that way, and this one's going to go up 3 units that way. So once we get that vertex, we can take a few points here, left and right, buy one, get one free. The negative 1/2 tells us it's going to flip about the x-axis, it's going to frown with that negative in front of it, and it's going to get fatter. Now, had that negative 1/2 been a number greater than 1, like if that was a 10, it would have been super skinny. All right, now I told you completing the square was back, so here we go. Now we're taking an equation that's in the other form here, which is called what? Quadratic form of a function. And we're going to write this using completing the square in that nice form where we can get the vertex nice. So what I'm going to show you here is the blankety blanks are back, but I'm keeping the blankety blanks on the same side of the equation. So in other words, this is y equals something. We don't want to mess with that. So if y'all remember, I just took this 7 and I kind of swung it over here so we could complete the square. I got the x's with the x's and just slid that number over. If we take half of that negative 6 and square it, we're going to get a positive 9 there. Now the thing here is that since we're on the same side of the equation, to balance this, if we add 9 in there, we need to subtract 9 over here to balance it. Now, we used to add 9 to both sides in earlier sections, but here we have to keep it on the same side. And here's what I mean by that. we added and subtracted 9 on the same side to complete the square. This differs from what we've done in the past, all right? Now, once we do that, notice that we can factor this here into, very nicely, x minus minus, but 3, and we can write this in this nice quadratic form, x minus 3 quantity square minus 2, and we get the vertex from there. So we can change from this quadratic form into standard form by completing the square on the same side. What's that? You need another example? I can hear students in class already. But before we do, we went ahead and we showed you the graph of this thing. All right, so we got the vertex at 3, -2. They did some buy one, get one frees, and I think y'all can figure it out from there. I like to give you plenty of examples. Now, here's your worst nightmare right here. This one is vicious because it's got the -3 out front completing the square. All right, so in this one, and remember, to complete the square, this number in front of the x square must be a 1. So they factored a 3 out of each term, and then they set up the blankety blank. They still took that 1 and moved him over, but the x values, they took a -3 out. Now, you can check that, because if you distributed this -3 through there, you would get what you started with. All right? Now, half of 2/3, if you're going to complete the square, would be 1/3. So I'm going to write that right above here, and I'll get to it in other graphics too. Now, if you square 1/3, you get 1/9. Now, before I move on here, here's the danger. A lot of students will say, okay, we got plus 1/9 here. Let's subtract 1/9 over here, but they forget that there is a -3 out in front of this whole thing. So when I added the 1/9, I've got -3 times 1/9. So if you think about multiplying those together, if I were distributing, I would get -1/3 here, with that -3 impacting the 1/9. So I would have to come over and add +1/3. So be careful here, and we'll show that. All right, so with that -3, where we had it here, with the 1/9, we also have to go -3 times -1/9 to get that factored creature. All right, so notice this will factor, once you get it, into x plus 1/3. And then we'll put the numbers together here. So this would be a plus 1/3. The -3 times -1/9 plus 1 would give us 1 1/3, or 4/3, and I think y'all can see the vertex from there is going to be what? -1/3, 4/3. Okay. Then what we're going to do here is we're going to go ahead and we're going to get the y-intercept. So here's some other ways you can graph parabolas. I mean, easy points to get. So if you put 0 in for the x's, what's y going to be? Well, it's going to be 1. All right, you can also get the x-intercept by letting y be 0 in solving. And this is just review of x and y-intercepts. And notice that the x-intercepts would be at 1/3 or -1. And then there is our frowny looking graph with all the fun fractions in it, which we know you love. All right, so we will come back and show you a little easier way to do this in the next video. If you don't like completing the square, I'll show you another way to do it that's easier. Professor Bob Young signing off.